Hello again. So, part C, control using an Arduino in digital design and embedded software. So, we're going to be looking about how we use control with an Arduino. So, looking for different conditional statements. They're called conditionals in general. We'll look at the if-else statement, comparison operators. So, what we use as the comparison within the if statement, and also conditions. We've got the for loop iteration, so we'll repeat a loop so many times. We will look at arrays, why and when arrays are useful. We'll look at an example of switch case statements. So this could be a replacement for multiple for loops. Switch case statements and keyboard inputs. So the if-else statement or comparison operators and conditions section. So if-else statements give programmers several options for setting conditions. If the first condition isn't met, the program will check the next condition. Comparison operators such as greater than, less than, or equal to. Notice the double equals sign. Otherwise, if we only used a single equals sign, it would mean like A equals B. Whereas A double equals sign means does A equal B? And there are other operators you are sure to be familiar with. I have mentioned some earlier in this lecture. A qualifier changes the properties of a variable. So plus, for example. A variable with a qualifier const in front of its declaration is a constant variable. These variables can't be changed anywhere in a sketch once they've been declared. The perfect choice for setting up instructions to run only when certain conditions were met, for example, is if. If 30 seconds have passed, stop the heating element. Or if the sensor perceives a wall, turn 180 degrees. So here we have an example in which we have an LED connected to pin 13 with a resistor connected to the pin and then connected to ground, and then a 220 ohm resistor, sorry. We have a potentiometer connected to a 0, and either side of the variable resistor or the potentiometer goes to ground and 5 volts. These are in line here, and that means the breadboard is connected. So we will move over to the if-else example in Tinkercad. So what we're going to do, in fact I'll do that in a second. What we're going to do in the sketch is measure the voltage at the analog pin from 0 to 1023, so the minimum and the maximum value. This voltage changed based on where the wiper, the potentiometer, is set, as I showed in the previous section. Define a threshold value somewhere within this range. For example, pick the number 400, and when the measurement is at the analog pin is above 400, turn on the LED at pin 13. When the voltage is below 400, turn it off. Well, that sounds simple. So let's go to the correct tab. So here we have our circuit already connected. Looks slightly different in Tinkercad, just a different view of the potentiometer. I'm using the scope here to monitor the voltage, and also ammeter and voltmeter to show the voltage across the through the resistor and across the LED. So I'll start it working to start with. Check, do we have? So we have 634. Our threshold is 400. So after 400, then the LED is on. The LED dropping voltage is 2.32 volts. We have 52.3 milliamps through the LED and from the pin because of this resistor. If we didn't have this 220 ohm resistor, then we may put too much current on that pin and ruin the board. So what I'm going to do is I'm going to drop it down, and now we see that the LED is off and we have no voltage and no current. So I'm going to bring it as close to 400 as I can. I'm not sure how easy this will be. So we're still off. And then we're on. Off. Off. On. Off. You will notice a bit of a time lag here. This is because it's an online simulation platform, and that's the easiest way for me to demonstrate this to you in a lecture. It's good for testing out, however, you obviously won't get this delay with hardware. So I'm going to stop the simulation and I'm just going to have a look at the code that we have. So we've got a constant integer, so we're using these constant integers that don't change because the analog pin is always going to be A0 throughout the duration of the simulation. The LED pin is pin 13 and the threshold is 400. We set the LED pin to output and start the communication with the serial monitor at a baud rate of 9600 baud. So we read the analog pin. We use the function, as we did in the previous example, analog read, and give this the value analog value, which is an integer. So if analog value, in this case, is greater than the threshold, then make the LED high. Make digital pin 13 high, so provide it with 5 volts. Otherwise, make it low. Provide it with 0 volts. And we're printing out in the serial monitor the value of analog value. We're delaying this. We're delaying 1 millisecond to ensure stability, because otherwise it would be an infinite loop and it may go too fast for the Arduino to cope with. So I've just gone through the code in Tinkercad. This is exactly the same information here. So the variables that have const in front of them never change. The variables are analog pin and LED pin. They're those pins the potentiometer and LED will be attached to on the Arduino board. Threshold is the number chosen to turn the LED on or off at. And there we have the explanation of the code. Set the mode of the pin here, and serial communications here. All the pins are by default set to input. So we do not need to have explicitly set pin mode for analog pin A0. That's why it doesn't appear here. We can do it, but we don't have to do it. It is best to do so for clarity. However, it hasn't been done in this example. Now we've got the loop. Read the value of the analog pin A0 and assign it to integer variable analog value. Compare the values that we just read from the pin to the threshold value, and then decide whether to write. If it's true, then analog value is greater than the threshold, turn the LED on. If not, turn the LED off. So if it's true, the code within the curly braces is executed. So this curly brace and this curly brace. Otherwise, this curly brace and this curly brace. So in general terms, if this condition is true, do 1. If it is false, anything else. So if it's not true, it's got to be false. Do this. Other comparison operators used on conditional statements, as I previously mentioned, we need to use the double equals to instead of the single equals to, or else we'll be changing the value of the variable. Is not equal to is an exclamation mark. Is less than, greater than, less than or equal to, or greater than or equal to, depending on whether we need to count up to the actual number or not. To ensure the program is doing as it should, then you should also make sure the potentiometer is working properly. So should really add a line to say the serial print line analog value. Now that was already in our program. So this line sends the values from the Arduino to your computer. So this gives you the power to debug your program, because it may not be doing what it's supposed to be doing. It may look like it is, but it might not be. So this line sends the values from the Arduino to the computer. You adjust the potentiometer and watch the values changed in the serial monitor window. Adjust the potentiometer so the value is right at the threshold, as I did in my demonstration, and make sure that the LED responds appropriately. The last line is to slow down the readings for stability. So you can try this for yourself in the lab, connect it up, adjust the values of the threshold value. I've given you the link again here. Write an additional if statement to turn on the LED when the analog value variable is less than 100. The LED should turn on when analog value is greater than 400, and less than 100. Further reading on this subject is provided at these two links. We will now move on from the if-else statement to the for loop iteration. The for loop allows us to run a piece of code over and over again, whilst incrementing a variable to count the number of iterations. Once a particular threshold is reached, then the for loop will stop. For loops allow programmers to do something in a very few lines of code what would take pages and pages of code otherwise. So for this example, we require 6 LEDs, 6 220 ohm resistors and jumper wires. So the circuit diagram for this this example is here is given in this figure here. So digital pins 2 to 7 are connected via 220 ohm resistors and LEDs to ground. So pins 2 to 7, here we connect each one to a row of the breadboard and connect that to the LED, and the other leg of the LED is connected to the ground rail, which is connected to the Arduino ground also. So that is how we read the diagram here. So we have made the connections for this, and each of these lines makes each of these lines. So on Tinkercad we have a for loop. I'm going to go to Tinkercad in a minute after explaining what the code's going to do. So we're going to have a timer. The higher the number, the slower the timing. So this is going to be the time in which the LEDs are going to be on. So the first loop is going to set pins 2 to 7 as output. Because as I previously mentioned, pins are automatically set as input. If we want to change them to output, then we have to physically do this. So a way in which we can do this is have a for loop, a variable called int this pin. So this pin is 2. This pin is less than 8, and then add 1 to this pin. So the first time we go through the loop, this pin is 2. This plus plus means after we've gone through the loop once, add 1 to this pin. So pin mode, this pin, so pin 2 is set as output. It will then go around the loop for the next iteration. So 3. 3 is still less than 8. So it will iterate, it will execute the code in the for loop this particular time. 4 all the way to 7. Why does it stop at 7? Because this condition is now no longer true. Because when it gets to 8, it is no longer less than 8, it is equal to 8. So it will repeat this loop 6 times. So from pin 2 to pin 7, which is what we wanted to. So just to reiterate what I've just said, in the for loop, int this pin, this is the initialize and declare the counter variable. The variable that's counting up each time the code is run. This is the test condition. This pin is less than 8. So this is tested each time on each iteration of the for loop. Increment after each time through the loop. So this pin is incremented 1 time every time through the loop. So we start off at 2. So pin mode 2 is output. Then pin mode 3 is output. All the way up until this pin gets to pin 7 and it's output. So it's any code which is between this bracket and this bracket. The open brace, it's called a brace, open brace and close brace. So the code between the curly braces is executed as long as the condition, the test condition, is met. So in a similar manner, then we can go around another for loop and turn each pin, or make this pin high for the time. So timer was set previously, so as the predetermined time. So we go from pin 2, set it high for a time, and then make it low. Then, so that's pin 2, go around the loop, pin 3 high, then low, round the loop all the way to pin 7. Each LED is turned on and on for 100 milliseconds and then off, starting from pin 2 until pin 7. So the opposite here is happening. So we've got another loop which looks exactly the same. The code's exactly the same in the center. However, the conditions for the for are different. So this time it starts off, this pin starts off at 7 and it decrements each time because we've got the minus minus here as opposed to the plus plus here. And the condition is greater than or equal to 2. So it starts off at 7, it decrements to 6, decrements to 5, all the way until it gets to 2. But it's this time it's a greater than or equal to, not less than as it was, and that less from 8. So the greater than or equal to it, so then it stops there. It won't get to 1. So again, we will set the particular pin high for 100 milliseconds and then low, starting from pin 7 and then till pin 2. So I'm going to go to the example, which is the for loop iteration. And I'm just going to, don't think we've got anything output to the serial monitor on this one, but I'm just going to start the simulation. You can see here that we are going to stop the simulation and increase it to delay time to 500 milliseconds. So the good thing about having all the variables at the top of your code is they're easy to change. Whereas here, 2 and 8 are in the for loop. It's not necessarily good practice, or it's not good practice to have numbers within the body of your code, because if you need to change them, then you need to remember to change them here, here, and also here and here, and also here and here. So there are 3 places where the numbers have to be changed. So that's not good practice, but we'll worry about that a bit later. So now the delay has increased, then we can see the LEDs switching on and off at an easier rate. So to sum it up, try this out for yourself in the lab. Adjust the value of the timer variable, which is what I just did. Add additional LEDs at pin 8 and 9 and adjust all 3 for loop statements accordingly. And then you've got some variable further readings such as variable scope, for loop, plus plus, minus minus, plus equals, minus equals. Thank you. We will now move on to arrays. An array is a data type that can store lists of information. An array is 0 index, so it starts at 0 and referred to by the number 0. For loops and arrays are very similar. you must always find one with the other. So index numbers. So if this is the array, my dog array is the name of the array. In the index number is 0, then the text is Spot in 0. In 1 is Rover. In 2 is Fluffy. 3 is Gizmo, and 4 is Pluto. The element numbers are 1 to 5, whereas the index numbers are 0 to 4. So this is the first element, but we refer to it as my dog array. Note the square brackets this time. Square brackets are important. So with arrays, it's square brackets. So my dog array equals Spot. Spot is a string or characters. My dog array 1 is Rover. My dog array 2 is Fluffy. My dog array 3 is Gizmo. And my dog array 4 is Pluto. Here we have a tutorial with arrays. So you'll notice it is exactly the same wiring diagram as the previous example. So we use pins 2 to 7 again. But what if in this instance, we didn't want to turn on these LEDs in order? So last time we switched the first one on and we did it this way, off, and then we switched them on and off in this direction. What if we didn't want to do that? How could we do that? Well, we'd use arrays. So it's the same circuit as the previous example, and it's a different sketch. So we initialize the timer, this time again as 100. Int LED pins. So we define an array called LED pins as integers, because in our integer we're going to store the pin numbers. So pin number 2 to 7 is being stored in LED pins. However, the pin numbers, the order in which they are placed here is the order that the LEDs are going to switch on and off at. So on the first pin to turn on is going to be pin 2, or the LED connected to pin 2, then pin 7, then pin 4, then pin 6, then pin 5, then pin 3. So all we need to know is how many pins are in the array. So we've got 1, 2, 3, 4, 5, 6 pins in the array. So the array contains integers, pins where LEDs are attached. Note, the pin number is not the same as its index. The index is LED pin 0 is 2. LED pin there's 6 of them, so LED pin 5 equals 3. 0, 1, 2, 3, 4, 5. So LED pin 3 equals what? 0, 1, 2, 3, 6. So that's pin 6. So the LED connected to pin 6 will turn on. Or I haven't seen it. I know it's going to turn on, but we haven't got to that part of the program yet. So in the same fashion as the previous program, in the void setup, we are going to initialize each of the 6 pins in the array LED pins to output. So similar way, for loop, int this pin equals 0, this pin less than pin count this time, this pin add 1 on. So LED pin 0. So LED pin 0 equals 2 on the first iteration. On the next iteration, when this pin starts off at 0, this pin moves to 1, then the next pin is pin 7. Then this pin goes to pin 2. So pin 2 shouldn't really be called this pin. I think this could be called index. So that would be for the fourth iteration of the loop, we'd have the index 3, which would be 6. The fifth iteration round the loop would be pin 5. The fifth iteration round the loop would be pin 3. Then there would be no more iterations around the loop because pin count is 6 and we've already got to 5. So when we got to 6, then this condition would not be true anymore. So starting at this pin equals 0 and adding 1 each time around the loop until this pin is 5. So we would then set the pins 2, 7, 4, 6, 5, 3 to outputs. Not in the logical order, but the order that we've set in the LED. So what order will the pins turn on or off at? So we've got the same loops here from this pin equals 0 to this pin is less than pin count. So pin count is 6 and we're adding 1 up this time. So we have, I can't remember what we had. We got 2, 7, 4. 2, 7, 4, 6, 5, 6, 5, 3. In fact, that is the order. So the index of 0 gives us a 2. So the first time round this loop, we get the 2. We're here. The next time round the loop, the index becomes a 1. So we then get 7. The third time round the loop, we get a 4. So this is the digital pin on this line. And this is the index. So this is referred to as LED pins, this pin. And this pin is the number counting from 0. This goes from 0 to 5. And the bottom row varies between 2 and 7 in the order that we have defined in the setup part of the program. No, not the setup, the declaration part of the program. Then after it's gone all the way at 6, 5, 3, so that's the first 0 iteration, 1, 2, 3, 4, 5. Then that's this block. So we'll write the particular pin to high for the time and then turn it off again. So the pins will come on and off in the specified order. Then it will do it backwards. So after we have got to this point, then we start from the bottom of the array. This will be the first time round the loop. This will be 0. This will be 1, 2, 3, 4, and 5. I hope this makes sense. So we will now go to the example on Tinkercad. So this is arrays. So again, it looks as it's the same circuit that's been wired up. Here's the array called LED pins 2, 7, 4, 6, 5, 3. So I'm going to keep that open so that we can check. I have increased the time there already. So 2. Still initializing. I didn't see from the start. Stop simulation. Start simulation. Oh, it's pin 2, isn't it? Start simulation, pin 2, 7, 4. I'm going to make the time even longer. So we start off at pin 2, then we go to pin 7, then we go to pin 4, then we go to pin 6, then we go to pin 5, then we go to pin 3. Then we stay at pin 3 and we count all the way backwards again. So try your own challenge in the lab. Switch the order of the values in the LED pins array. Make sure you use the same values, just change the order. Add another LED at pin 8 and adjust the LED pins. And then you've got some further reading. Now we have some switch case statements. Switch case, another in the next example. Switch case statements are useful when you want a list of options executed based on a variable value, such as a sensor. The break keyword is used in every case to exit from the switch case statement. So what we've got here is we've got an Arduino and we've got a photo cell or a photoresistor. We've got a resistor connected between ground and A0, and the photocell is connected between the pin A0 and 5 volts. So here we have the same circuit with the addition of a voltmeter. So the 5 volts and the photoresistor, the resistor and ground, and then this is connected to A0 and the voltmeter. So we've got a constant integer minimum as the reading on the lowest reading at an analog pin, and the constant integer at the max is 1023 is the highest reading at an analog pin. We've got int sensor reading equals analog read A0. So analog read the value at A0 and place it in the variable sensor reading. Int range. So we want to set our sensor to different ranges. So we have here map sensor reading min max, so between 0 and 1023, 0, 3. So here we've got the minimum value that we want to be mapped to and the maximum value we want to be mapped to. Here we've got an extra value. We've got 1 to 5 rather than 0 to 3 as I've got in this example. So between an input of 0 and 255, the output will be 0. Between 256 and 512, we'll get a 1 output. Between 513 and 768, we'll get a 2 output. And on the upper range, between 769 and 1023, we get a 3 output. Here we have the range directly from analog read, which is a figure of showing the same thing as the previous table. However, I've just corrected it as the 0, 1, 2, 3. So we can use this in the switch case statement. So a switch is something that changes based on different values. So if range is the resultant of the map of the sensor reading min max 0 to 3, so it's going to have values 0 to 3 is range. So it's either going to be 0, 1, 2, or 3. So if we say switch range, then if it is 0, so we can say case 0. So range is the variable we want to test against each of the cases. So we can say case 0, serial print line, low. The case is either matches the case variable or it doesn't. It's either true or it's false. Case 1, print line, serial print line medium to the serial monitor. Oh, what I didn't mention is we've got breaks here. So when we have a break, then we jump to the close brace that matched the open braces to the switch case statement. Case 2, we have a serial print high, and that jumps to break. Notice that there isn't a case 3 here, so nothing will be printed to the serial monitor in this case. This has now been added here as the ridiculously high value. So we'll go to the example. switch case. So this is the same code that's mentioned there, and I'm going to show the serial monitor. So we've got sensor readings 6 in this case. It's slightly different code, I do apologise. So we've got the range statements is, okay, sensor min 0 and 600. This is discovered through experiment for this particular sensor. We can scale sensors. This will be talked about later on another session. So the sensor reading is 6 here. That's as minimum as it can go. So I'll try and find the next range. So 278 gives us range 1. And we are dim, and you can see how I have used tabbing to make it easier to read the text. This is only for the useful for humans, whereas if it was just data, then you wouldn't need this tabbing. So my serial print is just my switch case is just printing the last bit of this data. If it's dark, dim, medium, bright, or too bright. So let's increase it a bit more to try and get to range 2. Did go backwards a little bit there. So range 2, I've just jumped to range 3. Range 2 is 581, then we were in range 3. So case 4, because there's no case 4, this is too bright. So we never get to too bright. You'll notice as I'm changing here that the voltage is changing. The maximum voltage, because of this resistor, is 3.32 at this point. So this is what's been dropped across the photoresistor to a minimum value here. Okay, so try this for yourself in the lab. Add an additional case to the switch case statement. You will have to expand the map range to do this, and then here's some further reading. So thank you for listening.